Okay, today we're in section 5.1. We're learning about ratios today. Ratios is a concept you should probably be familiar with. It is a comparison of two quantities. So double check your notes. You're going to have some blanks here to fill in your notes. A ratio is a comparison of two quantities. There are three ways to write a ratio. You can write a ratio with the word to, A to B, A colon B, and A over B. You can write it as a fraction, okay? Any of those ways would be acceptable. However, you'll find that when we're working through the lesson, you're probably going to gravitate towards fractions, okay? This last statement is really important, okay? A ratio is basically dividing the first quantity by the second quantity, okay? And what that means is, yes, it is a comparison, but this is how I would find a value of the ratio, to divide the first quantity by the second quantity. All right, so that's important. Okay. In example 1, you make flubber using the ingredients in the table. Has anyone ever made slime? Anyone ever made slime or just made something in general, like you cooked with it or whatnot? Okay, so usually the ingredients that you use to make something, you don't just do the same thing for every ingredient. Like one cup, dump it all in the pot together and stir it together. All right, so how do you know how much of something to use? What you were using there is a ratio, a value compared to another value. All right, so that's what we're going to do with cold water to glue. We're going to write a ratio of cold water to glue. And we see, okay, so I'm going to point something out. We don't necessarily have to address it here, but I need to look at the units. Are they all the same unit? So if I were to compare cold water to the borax, that would be a problem because I would not be comparing in the same unit. That makes a huge difference. With ratios, we must always compare values in the same unit. For example, if I said, I rode 6 miles on my bike yesterday, all right, and you said, that's nothing. I rode 6 feet. Is that the same thing? Would you be like, whoa, I mean, oh my goodness, wow. No, it's not the same unit. Exactly, okay? So to compare values in the same unit, all right, it makes a huge difference. So make sure when you're writing your ratios, and I had the question last hour, they're like, are we going to see values not in the same unit? Probably, okay, at some point in chapter 5, we are going to cross that bridge. We're just not doing it right now. So for cold water to glue, cold water is 3/2 cups, all right? So 3 seconds, okay? 3 over 2, compared to 2, okay? That's the ratio. I could write it with a colon. I could write it with the word 2. I could write it as a fraction. Now, if I wrote it as a fraction, that would look like, what was that word that I used to describe something like this? So let's see. Yeah, it's a complex fraction. Now, I would suggest, now remember when I taught you complex fractions, I taught you to actually write them side by side, to take what's in the denominator and write it side by side. So I actually don't want you to write it, okay, as a fraction. I would rather you write it as division. Because remember what we said about ratios. It basically is dividing the first value by the second value. And when that happens, when you do that, you find the value of the ratio. If I were to tell you what is the key, what is the code to cracking this entire lesson, okay, and understanding everything I'm going to give you a lot of different numbers today. What's the key to getting all of it? It's the value of the ratio. If you can find the value of the ratio, you can scale these ratios any way you want, and you're going to see how that works in a minute. How do you do that? You take the first value in the ratio and you divide it by the second value. Okay? So 3/2 divided by 2. But you must remember, a whole number can be written as a fraction, can it not? So if I'm dividing values, I actually am doing my KFC method. 3/2 times 1/2. And now I can multiply. What's 3 times 1? 3. What's 2 times 2? And I have a value of the ratio. What does that mean? That means this is the amount that compares the cold water to the glue. All right? So here's how I would interpret this statement. I need an interpretation, must be in words. Okay? All right? That I will have, okay, and you can say this a couple different ways. There will be 3/4, or I'm sorry, yeah, that was 3/4. 3/4 the amount of cold water compared to glue. All right, compared to glue. So here's what I'm saying. If I understand, all right, if I understand the value between these two, okay, meaning that there's 3/4 the amount of cold water compared to glue. All right, let's make it a little simpler and I say half. There's half the amount of cold water compared to glue, half, okay? If I said there was 2 cups of glue, how much would there be of cold water if there was half? 1 cup, because you would half it. So what I'm saying is, however much glue I have, there will be 3/4 of that amount of water, okay? That's the interpretation. The value of the ratio is how the first amount compares to the second amount. Does that make sense? So if I told you it was half, you would just cut it in half. All right? The value and the ratio, that's the most important part. So let's talk about equivalent ratios for a minute. Let's talk about equivalent ratios for a minute. All right? An equivalent ratio, when it's reduced all the way, is the same exact fraction. Do you agree that 2/4 could be reduced to be 1/2? You guys agree with that? You agree with that? Okay. All right, that's very good. Okay, so that means that they are equivalent ratios. Can anybody give me another equivalent ratio? Anybody give me another one? It's another equivalent ratio. Hadley?
1/3 to 2/6.
Okay, so just to 1/2. Sorry, let me rephrase that. Give me another equivalent ratio that would be equal to 1/2. All right, could you give me one of those? So you don't have to give me different ratio. We're sticking with 1/2. Hannah?
4/8.
Okay, 4/8. Very good. Give me another one. Give me another one. Samuel?
5/10.
5/10. Very good. Give me another one. Isla?
12.
6/12. Sorry, keeping on with the pattern. Okay, very good. Aiden?
50 100.
Okay, 50/100. So anything that could reduce to 1/2, right? And what you just did without realizing it is you applied a value to this ratio, okay? And when you did that, you were able to scale it, okay? But it still had the same value when it's reduced all the way. That's what we're going to do in these ratio tables, okay? We're going to find the missing values. And the way that we do that, this is the key. We must find the value of the ratio. Remember what I said at the beginning of the lesson. I said to find the value of the ratio, I must divide the first quantity by the second quantity. The order matters, okay? So whenever I'm filling in these ratio tables, I must find the column that has the top and the bottom value filled in. I have to know both sides of it. You see how the other ones have too many blanks, okay? But there's always going to be one that gives you both sides. Ask myself, from the first value to the second value, meaning from the top value to the bottom value, regardless if the number is bigger, okay? Because that missing value might be a fraction. So how could I get, it's only division or multiplication. How could I get from 18 to 3? What would be that missing value? And look here, it works in the opposite direction for the opposite operation. Okay, so what's my missing number, Isla? 6 is my missing value. So notice, if I'm working from the first value down to the second value, it is division. and it will always be division. Okay? If I'm working from the bottom value up to the top value, it is multiplication, and it will always be multiplication. Again, it doesn't matter if the values are bigger or smaller, because your value of your ratio might actually be a fraction. All right, we'll see that in a minute. So now that I have the value of the ratio, I'm going to fill that in across the whole table. Go ahead and fill in your value across the whole table. Okay, so it goes 6 all the way across. If I'm going from top value to bottom value, what operation is that to go from top to bottom?
Division.
Division. What operation is it to go from the bottom one to the top one? Multiplication. So let's go ahead and fill in the rest of the table. All right, so to go from 5 up, what would I do? 5 times 6, which is 30. Okay, and then to go from 42, yes, I would divide to get 7. Does everybody see how I got 7?
Yes.
And then, has anybody done the last one?
Yes.
All right, what is it, guys?
24.
24, okay? And here's what I've done, all right? I need you to understand this. This is really important, okay? I actually have the exact same value. If I were to take these, so 18 over 3. All right, please just write this underneath the table. 18 over 3. 30 over 5, 42 over 7, and 24 over 4. Would you guys agree if I reduce each one of these fractions? Actually, let's go ahead and do it. If I gave, these are ratios, right? I can write a ratio as a fraction, correct? Could I have written this 18 colon 3? Yeah, I could have done that all the way across. Would you guys agree that each one of these ratios has the same value? Okay, so what I've done here is I have equivalent ratios. Okay, now the only reason I'm showing you this underneath is to show you that with ratio tables, it is simply a combination of equivalent ratios. They all have the same value. All right, it's not a ratio table unless that is true. So basically, if I were to reduce one of those fractions and it wasn't 6, I did something wrong. All right, you with me? Let's do another one. Now, there was an error with my notes printing, so I apologize. You're actually going to have to flip a page into your 5.2. All right, so you think, oh, we're done with our assignment. Well, not quite. Keep flipping to the back of your 5.2. All right, so I don't know. Something got out of order, so I apologize for that. Okay, so we're going to do a few more of these ratio tables. What do you notice that's different about this one? What do you notice? You see some fractions in here, right? But my rule is still the same, okay? That in order to find the value of the ratio, what do? Yes, the first value by the second value. So I have to find one where I know the top and the bottom, okay? And that's going to be the first one here. Okay, my rule says to find the value of the ratio. And again, for it to be a ratio table, it has to be the same value all the way across. I must divide the first number by the second number. So here we go. 3 divided by 3/4. 3 divided by 3/4. Do you think we could do that? Do the KFC? Go ahead and do that. Find the value of this ratio. Again, once you find one, you can fill in the rest. So flip the second fraction and multiply 3 over 1 times 4 over 3. Okay? 3 over 1 times 4 over 3. Did you cross reduce? Did you get a value of 4?
Yes.
Who got a value of 4? Raise your hand if you got a value of 4. Okay, so now that I know the value of the ratio, I'm going to fill it in all the way across. 4. Okay? And remember, if I'm going top to bottom, am I multiplying or dividing? Top to bottom. I'm dividing. If I'm going bottom value to the top value solving, I'm multiplying by this value. Okay, so for my second block, what would go in the bottom? Someone raise your hand and tell me. What would go in the bottom, Colin?
3.
It would go a 3. Okay? Now, just like you had a fraction here in the first block, it's not uncommon to have fractions and decimals. All right, so I'm saying that to set you up for the last two blocks. Go ahead and fill in the last two blocks. When you have them, I'd like you to compare your answers with your neighbor. Okay? There you go.
Good.
All right. Okay, so 15 divided by 4, that was not a whole number, was it? All right, did you get 3 3/4?
Yes.
If you put 3.75, that is okay also. A decimal value would be fine. Okay, Hadley?
What if you put the improper fraction?
That would be okay. That'd be all right. Okay, and then for our top value on the last block, what would it be?
5.
It would be 5. Okay, very good. Good job. Who got them both? Anybody get them both? All right, so we're using the same value. And here's what we did, though. I need you to understand this. We created a series of equivalent ratios. Okay? Meaning, I've got a ratio here, 3 3/4, 12 3, 15 3 3/4. And the value of the ratio was 4 all the way across. They are equivalent ratios. Are you making that connection?
Yeah.
I created equivalent ratios. That's what we're doing in a ratio table. All right, so I want you to do this last one. Okay, go ahead and do this last one. It's the most challenging because the value of our ratio is not a whole number. Okay, so go ahead and find your value of your ratio and then fill in the rest of this table, please. Okay, Maddie, tell me what you did to find the value of the ratio. You can tell me what you got once you flipped it. Times 1/4. Very good. Did you guys get 5/8?
Yes.
All right. So here's what I'm saying. If you had to interpret what you're about to do, okay? 5/8 is the value. So here's what I'm saying. Okay? For every value of kilometer, okay, it will be 5/8 the value of hours. Okay? It will be 5/8. So however far I'm traveling in kilometers, it will always be 5/8 of the time, basically, in hours. All right? So 5/8 all the way across. Which means if I travel 16 hours, I can use this ratio, this value, to figure out how many kilometers I would travel. All right? And then on the flip side, if I travel 5 kilometers, I can use my value of my ratio to figure out how many hours that would take. All right? So for the second block, if I drive 16 hours and the value of my ratio is 5/8, how many kilometers did I travel? Do you see how I'm doing that with my words? See how I'm doing that? You're about to do it. Okay, Colin, what did you get for that blank? 10. Did y'all get 10?
Yes.
Raise your hand if you got 10. Okay, so we're catching on to this methodology here. He had to multiply 16 times 5/8 to get 10. All right, now this one I have to divide. 5 divided by 5/8, which would mean another KFC. Isla, what'd you get?
8.
Okay, do you agree with her?
Yes.
8. So remember what this means. If I travel 5 kilometers, it takes me 8 hours because the value of this ratio is 5/8. However long I travel, okay, the hours, okay, the distance will be 5/8 of that amount. So let's go to our last example. You mix 2/3 teaspoons of baking soda with 3 teaspoons of salt. Find and interpret the value of the ratio. All right, so I did you a favor here. You're comparing the same unit. I can't always say that'll be the case. Now, you might be talking inches versus feet. I'm not going to give you an overly difficult unit to convert, okay? And I will prepare you for that. In this case, I don't have to do any conversions. My chair twisted. All right. In this case, you don't have to do any conversions. So the first thing you're going to do is you're going to put this into a ratio, okay? You mix 2/3 of a teaspoon of baking soda with 3 teaspoons of salt. Find and interpret the value of this ratio of baking soda to salt. All right? So we have a ratio here. 2/3, it's baking soda. 2 salt, okay? I can compare it with a colon, okay? The salt is 3 teaspoons or 3/1. All right? Now, if I want to find the value, what did I say I need to do to find the value of a ratio? Someone raise your hand. How am I going to find the value of this ratio, Jack? Divide what? Yeah, the first one by the second one. So instead of a colon, I'm just going to divide. Divide. 2/3 divided by 3/1. Now, I got a rule here, right, Lydia? What do I need to do to calculate this? You remember what to do? Can I just... Yeah, very good. Okay, so 2/3 times 1/3, which is going to be what? Okay, it's going to be 2/9. All right, now I want you to put this into a sentence. I want you to put this into a sentence. Okay, can you put it into a sentence? Can you interpret this ratio? Can you interpret the ratio, the value? Remember what we were just doing in the last example? Could anybody put that into a sentence? What do you think? What do you think? Colin?
There are 2/3 the amount of baking soda that there are teaspoons of salt.
Perfect. Okay. Not 2/3, but 2
Oh, yeah.
ninths. Yeah, which is what you meant. Okay. So what he said was there is 2 ninths the amount of baking soda compared to salt. All right, so what does that mean? It's not a 1-to-1 ratio, right? It's not a teaspoon of baking soda, a teaspoon of salt, right? It's 2 ninths of that amount. So however much salt I'm using, I will use 2 ninths of that amount of baking soda. All right, you see how they relate? So I found that conversion rate. That's called the value of the ratio. If that was half, then I would just cut the numbers in half. Okay, but it's 2 ninths. All right, did you guys get that? Did you get the interpretation piece? So that's probably one of the harder parts, is to understand the value of the ratio is actually what I'm doing to one amount to get to the second amount. All right, the value of the ratio. Okay, so that's everything you need to know for the lesson, and you have homework tonight, numbers 1, 4, 10 through 18 even. Please go ahead and get started on that.